So we've seen some slides with some code for how you could do inference on images using Android and TensorFlow Lite. But there's no substitute for digging into the code yourself and trying it out. The full Cats vs. Dogs app is in the GitHub for this course, so download it and give it a shot. I'll walk you through it in this video. Let's take a look at the Android app for Cats vs. Dogs. We'll start by opening it in Android Studio. The source code for this app is available in the course GitHub. Within the Assets folder, you'll see the files containing the labels, which is just a flat text file with one label per line, such as cat and dog. You'll also see the converted TF Lite model. This is a binary, so it can't be opened and inspected in Android Studio. Your build.gradle file will contain the reference to the TensorFlow Lite runtime, as well as the options to tell the compiler not to compress the TF Lite file. The images are just stored as resources within the app for simplicity. In a real-world app, you'll probably read from the camera stream and classify what you see, and you'll see that in a later lesson. The image classifier activity is where the real work takes place. And its UI is defined from the layout file, which you can see here. It contains a number of image view controls which are hard-coded to contain the resources we saw earlier. You can see this line of code, set content view, which handles that. It's pointed at the layout file. Init views then loads the image resources into the respective image view controls. The main workhorse of the app is in the onClick function. This is the one we looked at in the slides, where we load the bitmap from the control that the user selects. We then pass this to the recognize image method of the classifier. This will return a result that we will then render as a pop-up message, which in Android parlance is called a toast. The classifier is a class that uses the TensorFlow Lite interpreter. We'll take a look at that next. There's a lot going on here, and we can see the code that initializes the interpreter, setting up the number of threads to use and indicating that it should use the neural network's API. But let's focus on recognize image first. This is the code that does the data pre-processing, taking our image and scaling it to the input size and color depth that the neural network model recognizes. We first scale the bitmap. Then we convert it to a byte buffer while mapping and normalizing its color channels, using the convert bitmap to byte buffer code. This takes the image and creates a byte buffer from its values, masking out the red, green, and blue channels as well as normalizing them. This gets the data ready for use by the model. We next initialize the arrays that will hold the results that come back from the model before finally invoking the interpreter, giving it the data and the results array which it will write to. I'll put a breakpoint here so we can inspect the behavior at runtime. These results are processed by getSortedResult, which is a function you'll use in a few apps this week. The results from a neural network for classification are an array containing the probabilities for each class. This function loads all the results above a threshold probability into an Android priority queue, which helps us sort them. For cats versus dogs, it's a little bit of an overkill, but later when you look at classifiers that handle 1,000 classes, you'll be able to use the same code.